Okay, we're on problem 3. Our first step is to factor anything that can be factored. So we can factor this quadratic right here. What multiplies to negative 48 and adds to 2? That's 8 and negative 6. We don't have any monomials to simplify. Can we cancel anything out in the numerator and denominator? The y plus 8. Now, that y minus 6 is still in the denominator. It doesn't automatically get to hop up to the numerator just because the numerator's gone. What do we put in place of the numerator? 1, since y plus 8 divided by y plus 8 is 1. Good job. Okay, number 4. How can we factor the numerator? First, we factor out a GCF. We can do the same thing in the denominator. We can factor out a GCF there. Oh, wait, the GCF is 8, not 4. But there's more factoring to be done. We have a quadratic in the numerator. We can say what multiplies to negative 20 and adds to negative 1. So that would be r plus 4, r minus 5. Again, we don't have any monomials. Well, we have the 2, but nothing to simplify with the 2. And the r plus 4. Those go away, and we have 2 times r minus 5, which you could leave like that. There's an 8 there. That's why. Okay, very good. I needed to be called out on that. There's the 8. All right, so now we do have monomials. The 2 is a monomial, the 8 is a monomial, and so we can reduce that. What does that become? 1/4. And then the r plus 4's cancel out. So this becomes 1/4. The r plus 4's cancel out, and we have 1 times r minus 5 in the numerator, and then just a 4 in the denominator. And that is the simplified form. What questions do you have so far? I'll pause it. Questions? All right, so there's a little tricky business when we get down to one like number 5. Let's just start it like normal. P squared minus 49. How do we factor that? Difference of squares, which means you take the square roots and you put a plus and a minus in between those square roots. Now we desperately want to cancel out p minus 7 and 7 minus p and be done with this problem. But p minus 7 is different from 7 minus p. They're opposites. But I still want to cancel them out. So guess what I do? I factor out a negative 1 from the 7 minus p. Here's what I do. I keep the p plus 7 and the p minus 7 in the numerator. But in the denominator, I do negative 1 times p minus 7. 7 minus p is the opposite of p minus 7. That would give me the negative p and the positive 7. Does that make sense? This is just another way of writing 7 minus p. But it's a very convenient way, because if you write it that way, we can cancel out the p minus 7s, and then we have p plus 7 divided by negative 1. So that's negative p minus 7 for your final answer. Why don't you try 6, 7, and 8 on your own? Well, I meant to pause the recording, and I paused the screen. Whitney, I wasn't going to record this, but I'm recording it now because your class had a hard time.
It's frozen.
Oh, it's frozen. So, first thing we do here is factor out a GCF of 3a. And that leaves you with 4a squared minus 1. And down here, 6a squared times 2a plus 1. So many of you wanted to cancel out the 12a cubes. Plus and minus signs. What they put together, I'm going to say, what are y'all? Algebra 2 students separate. Don't let anybody separate, okay? Don't separate plus and minus signs, okay? They cannot. You can't just take part of something and cancel it out with part of something else.
What if it was 2 plus signs?
Okay, so pause. Back to our problem. This numerator can be factored further. We could make that 3a. This is the difference of squares. So 2a plus 1, 2a minus 1. And then we see that the 2a plus 1s cancel each other out. 3 goes into 6 2 times. A divided by a squared is what? A. And where does that a go? Does it go on the top or the bottom? The bottom, because our a squared, our bigger number, was on bottom. So we have 2a minus 1 on top. That makes me unhappy. I don't have room to write the answer. So 2a minus 1 on top. I'll just write it down here. And on the bottom we have a times 2 left, which is 2a. And no, you cannot cancel those out. Okay, this one is married to that one with a minus sign. You cannot. Yeah, plus and minus signs marry. Oh yeah, I've said that 10 times, right? Yes. Okay, so this is your answer. Questions? And y'all did so much better on the last one once we reviewed how to factor. You did so much better. Factor out a 5 here. Some of you factored out a negative 5. How many people factored out a negative? How many people factored out a negative 5 to begin with? Not many. Okay, so y'all factored out a 5, I hope, and got 9 minus w. When you factored this in the denominator, 3w, w, 9, 1, minus. So you see this and you go, hey, I've got 9 minus w and w minus 9. I want to cancel those out. What do I need to do to be able to cancel those out? I need to multiply or pull out a negative 1. So I'm going to cancel those out and multiply by a negative. So that's going to be negative 5 over 3w minus 1. Some of you might have put 5 over negative 3w plus 1. That's the same thing. Some of you put the negative just right out here to the side. That's the same thing. All of those are equivalent. All right, flip on the back.
Wait.
Please. And dividing rational expressions. To multiply, guess what we do, guys? We factor everything, and then when you factor, say, thank you, 3/4 times 2/5, okay? You cancel out here, or you multiply across, okay? It's easier, and then reduce. It's easier if you would cancel out the 2 and the 4 here. 2 goes into 4 twice, and you could multiply across. 3 times 1 is 3. 2 times 5 is 10. Okay? That's how we're going. Did anybody learn cross canceling? Like when you were learning to do? Okay. Learning to multiply fractions. What we're going to do is we're going to factor first, cancel out what we can, then multiply across. So here, I see that there's a 6 and an 18. 6 goes into 18 3 times. There's a 2 and a 10. 2 goes into 10 5 times. Now, some people don't like to do that. Some people prefer just to go ahead and multiply the whole thing out. I don't like to use a calculator, so I do that. So this gives me 5 in the numerator. X squared times x to the third is x to the fifth. Y to the third times y to the fourth is y to the seventh. Remember, when you're multiplying with exponents, you keep the base and add the exponents. So then we look at the denominator. The 2's been canceled out, but we have a 3. X squared, there's not 1 in this term, so we just have x squared. And then y squared times y squared is y to the 4th. Last step, we are going to simplify our variables. 5 minus 2, remember when you divide, you subtract the variables. 5 minus 2 is 3, and it goes in the numerator since the 5 was bigger. 7 minus 4 is 3, and it goes in the numerator. This is your final answer. Now in this second one, I'm going to model doing just all the multiplication first. So I'm not going to cross cancel anything. I'm just going to say 20 or 4 times 5 is 20. And then I've got a squared times a to the 3rd is a to the 5th. B squared times b to the 6th is b to the 8th. In the denominator, 15 times 12 is 180, I believe. Yep, 180. A to the 5th. Remember that has an understood 1 right there. And b to the 10th. And then you have to simplify. So 20 over 180 is going to be 1 over 9. Just going to leave the 9 there in the denominator. The a to the 5ths cancel out. Woo.
Miss Goddard?
Yes.
Can I have Lillian Tobias check out?
Sure.
Thank you.
You're welcome. And then we have b to the 8th divided by b to the 10th. B squared, where do I put it? In the bottom. So there's nothing left on top, so what do I put? 1. Any questions on that? The cross canceling does work good because you don't have to go 12 times 18. What is that? Carry a 1. You don't have to do any of that. All right, so on 11, we are going to factor out anything that we can factor. Okay, we're going to do all the factoring that we can. So here I can factor out a GCF of 4x. Have a good weekend. Here I can make that x plus 3, x minus 2. The denominator of this one I can factor out of 4x and get x plus 2. This one I'm going to have to take out a GCF first. That's going to be 2 times x squared plus 2x minus 3, which is plus 3 minus 1. I'm going to just go ahead and cross this one out since I factored it further here. And I'm going to see things that cancel out. Do that 4 and that 4. That x and that x. Even though they're in separate terms, when we multiply, we're going to end up just multiplying all the way across the top, all the way across the bottom. So we can just make this one big fraction. And we can cancel out the 4 and the x, the 4 and the x. Is there an x minus 1 to cancel out in the denominator? Yes. Is there an x plus 3 to cancel out? Yes. Is there an x minus 2 to cancel out? All right, so we've made it all the way across the numerator. So we know we're done. In the denominator, we're left with a 2 and an x plus 2. The end. You try number 12. Working this one out, when you factor everything, you end up with negative 5. No, you don't. You end up with positive 5v times 2 minus v times v minus 9 times v plus 1 over v minus 2 times v minus 9 times 15v. Okay, that was the factorization of everything. These are pretty simple factors. And I see that my 5v and my 15v, I can take that out and make that a 3 because 5 goes into 15 3 times and the v's cancel out. I want to cancel out this 2 minus v and the v minus 2, but when I want to do something flipped like that, what do I need to do? Multiply by a negative. So I'm going to multiply by a negative up here, which would make that v plus 2, negative, yeah, v plus 2. No, it wouldn't make it v minus 2. So I could cancel it out with that. And then my v minus 9 cancels out, and my final answer is negative v plus 1 over 3, which could also be written as v plus 1 over negative 3, which could also be written as negative v minus 1 over positive 3. This one is kind of frowned upon when you put the negative in the denominator, but it's not wrong. These two are more favorable. Questions? All right, we're almost done. The very last thing we're going to do is look at dividing. Now, if I'm just dividing 3/4 divided by 5/2, who remembers how to do that? Okay, I've heard all kinds of things, but yes, multiply by the reciprocal. Keep, flip, change. Switch the second one. All right, so you would keep the first one, flip the second one, change it to multiplication. And so this we could cancel out here and get 3/10 when we divide. Well, we're going to do the same thing with these dividing rational expressions. So if you need to write out here to help you remember, keep, flip, change. What that means is multiply by the reciprocal of the second fraction. Multiply by the reciprocal of the second fraction. What we're going to do is, since we can't factor any of these, we've just got monomials. This is a division sign, so that tells us to keep the first one, flip the second one. And change it to multiplication. Now you can go ahead and you can multiply straight across. I'm not promising that I know what 16 times 35 is off the top of my head. For me, it's easier to go ahead and cancel some. 5 goes into 35 how many times? And 8 goes into 16 twice. So for me, that's going to be a little bit easier to do that. And that leaves me with P. And then q times q to the 5th is q to the 6th. In the denominator, I have 2 times 7 is 14. P to the 3rd times p squared is p to the 5th. And I have the q squared. When I reduce this, there's no integer, no constant value to reduce. So I'm just going to leave that down here. Then I'm going to divide my p's. This one has an understood what? 1. 1 minus 5 is negative 4. So we have p to the 4th. Where do I put it? The bottom. Because a negative would go on bottom. You can look at it that way, or you can look at it as there are more p's on bottom to begin with. So leave it there. And then q to the 6th divided by q squared. 6 minus 2 is 4, but this time our bigger exponent, we have more q's on top. So we're going to leave the q there. And this is your answer. Any questions? All right, we're going to skip number 14 and go to number 15 for time's sake. What do we do first? We factor everything. You can do your own factoring. Alright, I did all my factoring. It took a while, but I did it. After I factor, then I multiply by the reciprocal, meaning I keep the first fraction, flip the second fraction, and change it to multiplication, which makes it one big fraction. Okay, so now that we have factored, we've done keep, flip, change, which is multiplying by the reciprocal, we start canceling. Does anything cancel with this 2? The a goes in there 4 times. What about a squared? Yes, there's another a squared. Okay, what about a minus 6? Yes. What about a minus 3? Well, we have a 3 minus a, so what must we do? We need to put a negative there. Then we can cancel them out. What about a minus 5? No. So we keep the negative, which I like to put out front, a minus 5 over 4 times a plus 2. Some will go ahead and distribute that negative in the numerator. That's another way of writing it. Either of these is fine with me. It's even fine with me if you make that positive a minus 5 over negative 4a minus 8. They're all the same. What is it? Oh, yeah. So distributing or not, I would. I didn't do it on that one. Thank you for asking.
So you said it's okay if we have a negative before.
Yes. And then if we did that, I would not leave a parentheses right here.